record this so we can upload it so you guys can review what we're talking about here. But you know, after we've trained that neural network initially on what's called half the periodic table, and then tested it against the other half of the periodic table and feel that we have some level of confidence that it is accurately predicting, is this an element or is not an element, then we have kind of an inkling of hope that we might have the ability of predicting effectively atomic systems using a neural network. Now, that doesn't mean they're actually going to be atomic systems, but we at least have a tool that we think is better than just a you know, a random coin flip of what's a potential element versus what isn't. So let's assume we have that tool. So attempt number one, train a neural network on half of the periodic table using reinforced learning as to whether something is an element or not an element. We'll say this will require us to create a data set of called half. Well, let's say a data set of the entire periodic table with call it the ability to turn certain variables on/off. All right, so we probably want to be able to read in a bunch of data about from the periodic table, you know, where each element has, you know, 10 pieces of information associated with it. We might decide that all 10 pieces of information isn't good. You know, we might ultimately determine that there's really 3 or 4 of those variables that ultimately drive whether something is likely an element versus likely not an element. And some of those other things are kind of extraneous. You know, they could be, you know, things that are kind of consequences of the other things, not necessarily the driving force of what made something an element. All right. So we want to have the ability, since we're gonna, you know, we're gonna write some software to generate these data sets, and we want to have the ability to modify our data sets quickly so that we can retrain the neural network with different versions of our data set with more or less detail, you know, such that we can see if we're getting better or worse results from it, something like that. All right. So I'm going to go ahead and add to this. We would then randomize known non-elements as inputs. Actually, you know what? I'm going to do this. I think this should maybe be an attempt 2. Because I do think it is worth looking at training a neural network with just the known elements first, rather than us adding any sort of random data into it. So if we took half the periodic table, we read in all the different variables, we created a data set to train a neural network with those variables, and with an ultimate goal of getting it to determine true every single one of these is an element. Because initially, when you first train the neural network, it's going to have a whole bunch of random values. And we want it to ultimately, we want the neural network to converge on a bunch of yeses. Yes, these are all elements, so that we can then show it other known elements that it's never seen before and see if it also becomes yes for all those. So I think for attempt number 1, it makes some reasonable sense not to have us randomly create fake elements. Does that make some sense?
Yes, yes, Professor, I understood.
Let me, so here we'll say, call it, perhaps we would then randomize not known non-elements as inputs to help train that network if it does not converge on the original training or does a poor job of predicting the elements that we tested it on after training. Okay, so our first attempt is going to be to determine, can we train a neural network on just half of the periodic table that we know are elements, with the hope of determining that the other half of the periodic table are also elements, and not get a whole bunch of no, this isn't an element, so on and so forth. Okay, so I think, let me let's call this guy element discovery research. All right, and then something up here. So if we look at a periodic table here, and like I hover over hydrogen as an example, we see over here on the left all of these different variables that go with hydrogen. Now, some of these might be helpful to us, some of them might not. So it's going to take some trial and error in terms of training these neural networks to know which which of these variables end up being important predictors for what's an element versus what's not an element. But I think we want to write some software that brings in all of this stuff. So we would have data structures. So maybe we would have maybe we have something here called the software for collecting the periodic table. So we would have a class named element. And inside this, we would have a name, a series. So this is part of the reactive nonmetals. Probably not going to be important for training, but if we're reading in the data anyways, we might as well get as much as we can.
Wait.
We want to have the atomic weight, energy level, electronegativity.
And the very important point, melting and boiling point.
Say, etc. All right, so we want to create some software that can hold all this information about an element. So we're going to say, create a list of known elements with each element containing, well, let's see, with each element represented as an instance of the element class described above. And then maybe display, let's see, how do I want to do this? I'm going to add a little something to our class named elements here. We're going to have the, instead of create a list of known elements, what I want to do is I probably want to say, create a class named element collection, or an element collection holds a list of elements, say element objects, and has the ability to suppress certain variables across all of the elements, with the goal of being able to generate various data sets with different levels of detail about each element for training our neural network. And then this guy probably should then have the ability to display the elements in a reasonable way. Let's say display the elements to the screen in a reasonable way that shows the level of detail we asked for. Right? Once we have this, we can start thinking about how we want to feed this into the neural network. All right. So kind of our step one here is not even going to deal with neural networks. It's going to deal with just writing a computer program that reads in as much data as we can from the periodic table, puts it into some objects that we can work with, and then gives us the ability to globally turn off certain aspects of those things. So maybe we decide, okay, well, we want to disable the like from this, the density. We don't want to see the density for any of these guys because our belief is the density is not going to be part of what's a good predictor for an element versus not an element. I don't know if that's a true statement or not, but that's the level of control we want to have over our data so that we can try different versions of our data as we're training the neural network. To see, what level of detail gives us the best results in terms of predicting, is this an element or not an element? Make some sense?
Yes, sir.
Okay.
Yes, Professor.
Yep. So I think that's really what we want to do for step number one with this is just get that software built that gives us effectively a object-oriented version of the periodic table to screw around with. And then we can start doing all sorts of interesting things with that data. I mean, one of the things you run into with research is you might be going down one path. So initially we're going down, this path where we are, finding out, can our neural network predict some stuff? Well, based on the results we get from some of our different tests, we might decide, well, the answer is no, it's not very good at predicting elements, but maybe we can use it to predict something else. Maybe we start noticing patterns in it or something like that. All right. And so, like I mentioned, a good thing to do with ChatGPT is you're trying to understand details of this. So let's just, going back to what I was talking about before. So let's see, to train a neural network for the purpose of predicting possible new elements or stable configurations of known elements, you would need a comprehensive data set that includes, so here's our periodic table information. So this is that data set we're creating. So ChatGPT has effectively told us we need to go write some software to build a data set, or at the very least find a data set that's already out there. And here's kind of the various levels of that data. Well, let's say we look at one of these things and so kind of this whole known molecules and compound stuff, these are data sets that I think we might ultimately try to create. So we're going to kind of follow the yellow brick road as we go down through here. But let's just say that thermodynamic data, let's just talk about that. So we might say in layman's terms, what is thermodynamic data? So let's say we don't really know what that means, or it's kind of so it talks about here information on the stability of compounds such as enthalpy and for formation, entropy, Gibbs free energy. Okay, well, whatever, let's just say in layman's terms, tell me more about this. So we'll go ahead and punch that in there. It's now going to give us some information. So it refers to the information about the energy changes and properties of substances as they undergo various processes. So now it's going to define each of those things for us so we get a little bit better idea of what those mean. They may end up being important to us, they might not be important to us. But understanding the kind of data we're dealing with is going to be important, especially as we go further and further down the rabbit hole. At the end of the day, and this is kind of an important thing with research. I'm going to just kind of make up a number, but I'm going to guess that 99% of all research ends in us saying this was a bad idea, or no, this doesn't work, or at the very least, here's the 50 things we tried and none of those worked. So you don't have to try these things. It's just something like that. So understand that when you do research, it's not always about getting good results. It's about getting results that are repeatable and trustable so that some other researcher can use what we've done and build on it. Whether what we did is spend a lot of time getting a whole bunch of wrong answers, let some future researcher know that, okay, well, we don't need to go down those, those paths. All right, makes some sense.
Yes, Professor.
All right. So, in my view, this is a pretty good use of tools like ChatGPT, where you can go back and forth with something like this. Maybe I tell it to give me more information on Gibbs free energy, whatever it is. So I'll sit there in some evening and I'll just have an hour-long conversation with this. I'm usually voice dictating, and then I turn on the voice so I have it read to me. So I'm effectively having a full conversation with an AI. It's my wife walking through in and out of the room and stuff like that. So I think these are good things to kind of drive your imagination. All right, so I want to kind of stop the slides at this point because I think this gives us our step one, what we want to accomplish in our very first step here. Now, tell me, what are your guys, what's your computer programming background or whatever? What languages, how much coding have you done? Comfort level, blah, blah, blah.
Uh,
Real.
so I'm actually worked with Java. Like I'm very fluent in Java when it comes to data structures, object-oriented programming, and also have a little bit of experience in various data analytics and data science libraries like Pandas, scikit-learn, a little bit about TensorFlow and Keras in Python.
Okay.
And yeah, and I also worked as a core banking developer where we used to use a proprietary software called JBC, which is an enterprise-based software which we can't use here. So that's my expertise.
Okay.
And coming to me, yeah, so I mean, I don't have any experience, but I'm an intermediate in Python language. I've known some data visualizations and like Seaborn and Matplotlib. But I used to work with one of my friend who started recently a startup like e-commerce website named Sova Skills. Yeah, we used to work together to build some website, like I mean the interfaces to the websites. Yeah.
Okay. So do you guys feel like you could work together, for our first step in kind of creating a piece of software that brings in our data from the periodic table and gives us some stuff to play with? Is that,
Yes, Professor. I think we can use Python in that case.
yeah, I don't care.
Because
The language
yeah,
doesn't.
okay, okay,
Ultimately,
and
it's going to generate a text file that we're going to use as input to the
yeah,
neural network. So it doesn't really matter how we got it.
yeah. So what I think is rather than a text file, what if we use a CSV or a Excel sheet?
Same
That's
thing.
good,
I
right?
mean, a CSV is a text file just separated by commas.
Yes, that's it.
Yeah,
Yeah.
so the format doesn't really matter. I mean, let's say you come back and you're demoing some software for me that puts it on the screen, in a
Yeah,
format that's
understood.
not going to be overly compatible with putting it into a neural network engine, whether it's TensorFlow or Amazon ML or whatever. That doesn't matter. We're 20 minutes away from putting it in a format that is going to be more compatible with that. As long as we have our data read in and we are proving that we can turn on and off variables, at that point we're 99% there, and it's just stupid, print statements that are going to change
Understood.
the output. And I don't care what language you guys use. My background's in
Okay.
language theory, so I know a lot of languages and I can pick up a programming language in probably 20 minutes. So it's these aren't important things. So whatever you guys are most comfortable with, that's fine with me.
Okay. Okay.
So what do you guys think in terms of time frame? What's your what's your guys' ability from a time commitment perspective? How long do you think, if we just look at this as step one, how long are you guys thinking it's going to take to at least have kind of something to show that we can look at and say, well, what needs to happen next? I'm not necessarily saying, let's wait for perfection, but, maybe get some stuff coming to the screen, maybe having hit your first one or two roadblocks, and then we can come back together and talk about what you have, what's wrong, what's not wrong, and that kind of stuff. What are you thinking in terms of time?
So
Mm,
for the first step, I think 1 week is enough for us.
Okay.
Yeah.
So do we want to just repeat this meeting next Thursday? Is that reasonable?
Yes,
Yeah.
yes, professor.
Yes.
Okay.
8th. Yeah, February 8th.
And I'm going to add you guys in as invites. Why would it not copy this with, oh, actually, I'm just going to do this. I don't need to create a new one. I'll just do that. All right. So you guys should have a new invite.
Yeah.
From me now, or an updated invite. Actually, I just changed the date of today's to next week.
Okay.
What I'll do is I'll put in our Slack channel a link to my slides, even though they're small now. It's a collaboration link, so as we add to them, it'll just automatically show up as with more stuff. And then I'll also upload this video to YouTube in a channel, and I'll put a link up there for that as well.
Okay.
You guys.
Okay.
I know I sent both of you an invite to the Slack channel.
Yes, 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 yes. We also joined Slack.
Yeah, I think only Rishi is in the, so Karthik, you're not in the channel?
Yes, sir, I am in, sir.
Oh, but you're not.
Yeah, I'm in. Yeah.
Oh, you have actually two different accounts?
No, no, no. Yeah, one account. Yeah. I'll recheck and I'll rejoin, sir. Sure.
Well, I see two accounts in here. I'm looking at Slack right now. And I see, that's weird. Oh, so you're online right now, right?
Yeah, yes, sir. Yeah, yeah.
Right here. So I just added you to this channel.
Yes, I just know. Yeah, just now. Yeah.
Okay. So you see it now?
Yeah.
Okay. So and here, let me just so we can test this. All right, and I'm gonna let you guys make changes to the presentation as well in case you bump into something and want to add some detail in there or something like that.
Yes.
Okay. So I just sent you a link that should open up in a web browser. I use Keynote, but it's same thing as PowerPoint. I don't, you can use whatever you want. If you're going to send me a document, I can convert it to whatever. Yeah, so let's start with that. I'll also put a link up on the for the YouTube. If you guys want, what probably makes sense for this is to create a Git repository on GitHub.
Okay.
Have you guys both used GitHub before?
Yes, yes, yes,
Yes,
bro.
yeah.
Okay.
It is.
So we probably want to have a private repository, and if you have a student account, that's free. It won't cost you anything, but if you're having problems initially, we can, we can make it a public account first, and we're not doing anything earth-shattering at the moment, but add me as a collaborator on
Okay.
there. And then that way we can kind of keep tabs on what's happening. But so we'll look to getting together, but also check Slack. Try to check at least once a day, or at least turn on notifications here. So because I want to keep as much of our communication in one place, and I think Slack makes the most sense for us. As you might imagine, I get a lot of emails every day,
Yeah.
like a lot. I mean, I probably get 500 emails a day.
Okay.
So it's easy for things to get buried inside of emails, and it's never my intent to miss them, but I miss them. Where if it's in here, I might be a little bit delayed for when I can sit down and respond, but at least I'll have it already categorized in this channel and can, convert my mind to what we're talking about. Okay, sound good?
Yes. Yes.
Okay, so we'll come back a week from now, and I'll see you on Zoom at 8 o'clock,
Okay.
and we'll see what we
I
got.
have a doubt, Professor, like regarding the data collection.
Sure.
So the system should collect the data or generate the data. Like, let's say, for example, by giving some basic properties like atomic number and number of electrons and protons, it should derive all the necessary properties. Or if we can find an existing data set with all these necessary properties, we need to filter the required properties from it.
I think the second. I mean,
Okay.
we're not reinventing stuff with our data
Okay.
set. We're just trying
Okay.
to create a easily modifiable data set. So
Okay. Okay.
if you find an existing data set that's out there that already has the whole periodic table in like a JSON
Okay.
document, let's say,
Okay.
that's fine. But what we want to do is we can use that as our source and read in from that, create instances
Okay.
of our objects, and then be able to turn on and off variables. We just want to have the convenience
Okay.
of
Okay. Yeah.
a
So then we
tool that
can,
can generate data.
yeah, we can easily do it with a data structure like a list or something. We can convert it.
Yeah. But if you look at the slides, what I suggested is we have two classes. One class called an element that captures
Elements.
details about an individual element from the periodic table. And then another
Okay.
class called element collection, or if you want to call it periodic table, that's fine, doesn't matter. But that guy is going to be that. So we would create an instance of element collection. We would fill it up with all the elements that we've read in from our data source or whatever. And then we'd have the ability of saying, turn on or off these certain variables. Maybe they're all on by default, and then we can go through
Okay.
and flip the switch off for 6 of them, and that would go across all of our elements, so that when we then display our current data source, it would show just the details across the board that we want to try
Okay.
on our neural network. So we're not doing anything with neural networks yet. What we're doing
Okay.
right now
Understood.
is data set
Data
preparation.
collection. Yeah.
Yep. With just the convenience of being able to, turn things on or off quickly. Because ultimately, our next step, or shortly, we want to start trying to build a neural network around some of this, and just seeing what level of detail from our information kind of gives us the best results.
Okay.
And that's just something that is, so having a easily generatable data set early on is going to be beneficial for that. So that you're not going back and deleting a bunch of crap from your data set every single time. You just run your program once, turn a couple of things on and off, hit start, and you got your new data. Feed it to the neural network, go grab some lunch, and see if you get crap results or good results.
Okay.
Make some sense?
Yeah. Yeah. Understood.
Okay, well, cool. So I will well, I'll probably see you Monday, but otherwise I'll see you on Zoom next week.
Yeah.
Okay.
All right. Have a good one, guys.
Yeah. Thank you, sir.
Thank
Yep.
you. Thank you, Professor. Thanks a lot for that.
Yeah. Have a nice day. Yeah.
Yep, take
See
care.
you on Monday. Bye.